Hi friends, welcome back. Today I am going to present you the tutorial lesson 2 of Power Block Assembly. Uh, last uh, lesson we have already discussed these topics. Up to this topic we have already discussed. I have shown you how all the parts we have made in our last session. So today I am going to show you from 6.6 how to make an assembly, how to add material, and all the remaining parts which I promised to discuss in the beginning of the session. So without wasting any more time, let's start. To create assembly, select file, new assembly. Create assembly. You have to place the components in the assembly workbench. So you have created the block, bottom brass, cover, top brass. So let us place block. You click and leave and press escape to exit. Once you click, the part is here. So in this assembly workbench also you have to constrain. So before constrain, let me show you some basic move. If you want to move this part, click move and click this part and you can move this. Rotate, click and you can rotate this, or you can use grip snap. If you click this, now you can see free drag planar in a planar surface. If you free drag, like you can drag this way. Continue, okay, enter. So let's first constrain this block with the center point. There is a constraint command. After you select the constraint, here is the mate, first mate, then there is angle, there is tangent, there is insert, there is symmetry. So there is motion, transitional constraint set also. We will come on this later one by one. First I will select this plane to the part YZ plane. Okay, so here you can see that if you deselect this, then the preview will not happen, can't preview this. So okay, apply, then YZ plane with then XZ plane with XZ plane, apply, then XY plane with XY plane, apply, close. So your part has constrained, the base has been constrained. Now let us bottom brass, bring bottom brass. Yeah, so to constrain this, you will have to constrain this also. So click constrain, you just select the cylindrical face, it will automatically select the axis. Okay, so now you know that there is this one. So if you select its axis with this and rotate, click opposed, so apply, cancel. So now this is constrained, okay, totally constrained. So let me bring back the top brass. So again constrain with this, but I want it in other way. Click this, apply, okay. Then you can constrain with plane. So now it's only the one constraint you have given to this part has been constrained, but in this only you have constrained the center, but other two constraints you have to give. So you can give anything, whatever you want. I prefer to constrain it with the axis, with the planes. I prefer to constrain this with the planes. So YZ plane, XY plane, apply. Now I want to constrain this XY plane with its YZ plane, apply. So actually I haven't given the dimension, so close this. You want 0 0 0 0, so it has been constrained. You can see, okay. Now just I need to bring the cover. So again constrain this axis with this. I want it to be other way, okay, apply. So give 0. Now I want to constrain this with this center, Now it has constrained. So go to view. If you want to change the view style, you want wireframe, okay. You want other type of options, realistic, shaded with edges, whatever you want, you can select that. Now I have assembled that, but I need bolted connection to be made here, like here, this one. This is a square head bolt, so I will show you how to easily add bolts. So go to now design. Here is bolted connection. Click on this. You must save the assembly document before creating a design accelerator component, okay. Then save this assembly. I say power block assembly, one assembly, save, yes to all, okay. After you select bolted connection, a new window will pop up on your screen. So here you can see various two types of threads, threaded connection, bolted connection. Two types of bolted connection are there. One is through all and one is blind connection. So in this case I want through all, so it's selected through all already, so let it be. And there is calculation, fatigue calculation. This is not part of this lesson. I will discuss this in my other tutorials, next tutorials. So there is a placement of your bolted connection. So 4 types of placement you can create: linear, concentric, on point, or bi-hole. Linear means like the way I will do now. So linear would be, if I go for linear, then it's start plane, then first edge, give dimension, another, give dimension, termination. Then it's asking for to select the termination plane. Select termination. You can see two holes has been created for these two different parts. One is one is for the cover and one is for the block. So if you want to change the type of the hole, then also you can select it from here, but I don't want to change it in this case. I want it to be I want to change the whole dia. So either you choose the type of fit you want close fit, normal fit, or loose fit. Then you can select this, or otherwise you can select threaded or custom also. So in this case, loose fit I want, so loose. In this case also I will select loose, select OK. Add fastener. It's asking me to add fastener. Now I will add bolts. I will go to IS and I will want a square head bolts. Square head selected. So basically right now you can see the preview of that bolt, M16 into 1110. So now I want to add fastener here. Washer, apply, click another fastener. Want a hex nut. I want to add a jam nut. If you check the part here, you can see that the square bolt with one washer, one hex nut and one jam nut. So in this case, to select a jam nut, click here, and in the IS section there is no jam nut. I don't know why I can't find any jam nut. And go to ANSI and you can see a jam nut. So select this jam nut. So after you created this, you here, if you select add, this is template library. If you select add, this template will be added so that you can use it in future. So it's now selected, made. Now you save this assembly, rename this IS2585 square bolt M16 into 130. Save it. Okay. After you save it, you can select this face, position this, select this plane, position this 15, if you select the termination face, then you can select this templates. If you select set, then whatever you have done in this bolted connection, it will be automatically changed to that, and you select apply. Again save the connection. 2585 square bolt M16 into 130. Save it. Okay. So the bolted connections has been made, you can see. So you can see the it's not has been constrained, so better you constrain this. For constraint, you go to assembly again, select this, select constraint, select this face, select angle this time, select this face and select directed angle. After select, you apply 0 angle, so it will be parallel. Again the same way, constraint, select this face or whatever face you want, select this face, select angle, directed angle, select 0, apply. Okay, so now the assembly is completed. Now I'm going to add material in this. Select, double click the part and select here. So I want it to be gray cast iron, gray, and the appearance, you can select the appearance from here, or you can select this appearance here, select. After you select, the appearance browser will come from here. You can select whatever you want. Let me consider this time orange. So if you click orange and click this arrow, it will be updated in this appearance documents. You select, you have not select, you select the cover, then select this, it will be converted to orange. So actually orange is not suitable for this. Let me change this. So olive green, cover olive green. Okay, now you can add some fillets all over the corners. So I will select loop and all fillets. All rounds, and select this value to 1 millimeter, 1 millimeter, apply. So cover has been close, save. Now double click on the base, select gray iron. From here select appearance, select the solid, select the block and select this. It will be converted, the appearance will be it will be converted as per your requirement. Now again use some fillets, so all fillets, all rounds, 1 millimeter, just to looks good, but for actual case this fillet might differ from what I am giving. I'm just giving two looks for just it's good look, just for a good look. Okay, so now I've given fillet and close it again. Yes, and now the brass, select brass, no need to select appearance. In this case the original appearance is quite enough. Select brass, soft yellow. Okay, save. Now we have added the materials, we have created the bolted assembly, so it is now completed. I think light olive, it should be light olive. So let me change it to, both the colors are not, olive green block. For go to view, select the shadows and reflection to give it more realistic view. So now go to environments, then Inventor Studio, go to view again, change the view to perspective. Okay, then render your image. It will ask you to select the aspect ratios, so I'm okay with the default aspect ratio. So you can change the lights from here also. Select render, and you can see the rendering has started. After the rendering has completed, save it to your desired folder. Close it, close, finish the studio. Now for sectional views, go to view, then you can see the end section. I want a 3/4 section, so this from here. If you want quarter section view, you want half section view, if you want 3/4 section view, so I want a 3/4 section view. Then select 3/4 section view, select this plane, say OK, then again select this plane and say select OK. So if you now you want to add some text, okay, no issue, you can add text from annotations. Go to annotate and text leader text. You can create anything you want. Okay, so now if you have completed this, then view, I want to end section view, then I'll go to presentation. Now go to file, new, create. You open this assembly file, open. Now to start to make any exploded view, or to make animation of your exploded view, or to make some animation of your assembly or disassembly procedure, select to a component, select the part you want to explode. I have selected both of this jam nut together. You can select this duration of your animation, this part 2.5. I say let it be 2.5. You can rotate this, you can move this. Okay, so okay, and then new snapshot, click new snapshot. Okay, so again you select this hex nut to a component and move it upwards, select OK, and select another snapshot. Then select the washers, again to a component, move it upwards and select OK and make a new snapshot. Now select the bolts and move it downwards. Hit OK and create new snapshot. Select to a components, again move it upwards, again move it upwards, say OK, create new snapshot. Now top brass to a component, new snapshot, select bottom brass, move upwards, OK, new snapshot, file, save this file. OK, so you can see if I play this, so the presentation part has now been completed. Now go to file, select new, Now I need drawing, so I'll go for NSI millimeter drawing, create. So drawing file will be created. After this drawing template has been opened, so I need a base view. So for base view I have to browse the folder. So I will go for the assembly, Palmer block assembly. So here is the front view. I can change the positioning of the view by selecting the view cube accordingly. So I want the front view, select OK. So the front view has been created. Now you have to project the views according to your desire. Create, project. Now you can see the projection style is in third angle projection. So if you want to change it to first angle, go to manage, style editor, go to view preferences and select to first angle, save and close. Now again come to place view and see it now as first angle projection, first angle projection. So if you want to add an exported view, then you can open that by browsing that view also. So you can see the also has been created, added, but for exact select the view and or double click any one of the view and go to display option and select threaded feature tangent. Okay, now you can see that all the tangent and all the faces are visible. So in this case also you select the display option, threaded feature, select. Okay, if you want to show the see the hidden lines, then select this view and style and hidden line, remove hidden lines. Okay, you can see that the hidden lines are visible now. You can deselect that. Okay, so now if you want another isometric view, you project the view accordingly. You project the view like this, then isometric view will be created. So now if you want to edit, you want to make the BOM, go to annotate. There is a command called part list. Okay, so click part list, structure, BOM view, parts only, structured, first level, all levels. Select this. I can select this view also. Okay, so you can see the BOM has been created. So first is block, you select balloon, this one is block, this one is cover, third one is black square bolts and 16 bolt, third one is, fourth one is washer, select, it will take accordingly. Continue. So if you want to edit the BOM part list, click here, and if you want to choose your column, then select here and select this choose your column option, column chooser, and then come to like I want it to know the mass, add this mass and material, add, okay, apply. Okay, now you can see two more column of mass and material has been added, and you can see the mass and material of this also. So there is the title block, which is by default as per NSI standard. Go to this option and select edit definition. So when you select edit definition, the title block will appear in a different window. So here you can select the company title, part number, division number, like description I select number block, part number, whatever you want to edit. Okay, you can select, you can change the division number from here also. Okay, then company, say you can select the company name also, and make, okay, finish sketch, yes. And you can see your assembly drawing with BOM has been created. So now if you want to convert this drawing file to AutoCAD version, now right now if you save it, it will be saved in Inventor IDW files. Say drawing 1, save. Okay, so now if you want to export this drawing to another option, to drawing file, before that I want to show you that if you want to change the sheet sizes or anything, so from here you can also change. Go to sheet, right click on it and edit sheet. Then suppose I want it to be A2, okay, or A2 is bit okay, okay. So if you want to save it to rest to all, okay, save, go to file, export to DWG. So the version you want to save, which version you want to save this, you want to export this, select next, base view, scale model space. So now save it in AutoCAD DWG files. Save. So now if you want to save this assembly to other formats, or so that you can open this from another software, then go to export and select CAD format, then save as type, whatever type you want, just select that, like Parasolid, IGS, CATIA or STP, STP, then select, then save it. Thank you for watching. If you really like this video, please subscribe to CADMake so that I can come up with more videos like this. So till then, everybody be safe and healthy. Once again, thank you. Bye.